welcome everybody to a new video of our series EWM Needs Automation. And this series we discover the MFS component of SAP EWM together with the EWM team at Swisslog. And with this video we will have a deeper look inside how EWM core actually integrates with its MFS component as well as with the actual subsystem, so the PLC level. Before we go into detail here, I would like to have a very quick look at the layer model which was created by the VDI, and what I would like to highlight here is the area where we are going to look at. If you want to get an introduction into the task and components of a PLC, I would recommend watching the last video that I published here. I will put a link here or put the video link somewhere here so you can derive the details from there. With this video here, we will concentrate on the communication between this level here, which could, in the context of EWM, be interpreted as one layer because the material flow component is integrated into the WMS when we talk about EWM. Yeah? The MFS component is covering the task to talk to the PLC level. So we interpret this as one layer, and we look at the integration between EWM and EWM MFS. So let's call it EWM core and EWM MFS. So how do these two parts of EWM integrate with each other? And we will also look at the integration between EWM, MFS, and the actual subsystem. So this is the topic of this video. We will look at the most important components within EWM MFS, how they interact with EWM core, and then we will have a quick look at the communication and the integration between EWM MFS and the subsystem itself. We will not go into detail in terms of like step-by-step communication flow between EWM and the subsystem and the other way around, because that is a bit more complex, and I will release 2 additional videos covering the communication step by step with all the technical details. But that shouldn't be part of this video, as it would be too much information and it would become way too long. Based on what I just explained with the layer model, we can break it down in an easier view here, because we are not interested in the top layer handling the deliveries, and we are not interested in the lowest layer covering the sensors and drives. So we only look at the WMS part, which is here EWM plus EWM MFS, and the subsystem, which is the PLC layer. So that's our simplified layer view for this video here. To make it a bit easier for you to follow, so that it's not only a pure theoretical here, I decided to grab an example. So in this pretty easy one, we assume, like on this picture, you see a conveyor, and the conveyor has an eye point over here. And on this conveyor, pellets can move from A to B. Just a very simple example, which is moving this object here, which is sitting on the segment 0333, we want to move it to 0111. So how is this going to happen? And what we are going to do here is to go through this step by step and identify the important objects in EWM and EWM MFS especially. So how does the pellet get from here to there? First of all, in EWM, we simply create a warehouse task from this bin to this bin. Yeah. So in EWM, we have bin A and bin B. And bin A is the one where the HU is sitting right now. That was highlighted in the previous picture. And bin B is where we want to go. So in EWM, it's nothing than a normal movement from bin A to bin B, with the difference now that we have so-called communication points assigned to those two storage bins. A storage bin, which is reflecting a physical conveyor segment in EWM, gets additional characteristics and attributes via an object called communication point. Yeah, so you can keep it like this. Whenever you assign a communication point to a storage bin, you are basically adding additional attributes and characteristics to this bin. And every bin which reflects a physical segment of a automation equipment needs to get the communication point assigned to it in EWM. Yeah, so we have the bins in EWM, which are enriched with additional data via the communication points, and this combination of bin and communication point reflects a physical conveyor segment on subsystem level. Yeah? So in our example, if I just go back, we just concentrate on these two bins, which are also communication points in EWM MFS, and physically these are two different conveyor segments. So in our example, we create a task from A to B. The HU should move via the conveyor, and the HU has the warehouse task and the warehouse order in EWM. That's the status. So how do we get from A to B now? Before we go there, just a quick look at the details of the communication points. I will give you this quick overview for each of the important components. And you see here that a communication point is master data enriched with customizing. We create the communication points, assign the storage bins, and enrich the communication points with additional customizing. For example, that this communication point is an I point, that it has a scanner, I can assign a clearing communication point, and so on and so on. Yeah. This mapping can be done manually one by one, or there are also bodies. If you have hundreds of communication points, if you have, for example, in a high bay, hundreds of bins which needs to be mapped, then you might just want to use a body and convert the string which reflects the storage bin in EWM to the communication point and vice versa. I gave you the bodies here also on the slide. That was the first important object. Remember, communication point. Next one. So how do we actually make our subsystem do something here? Because logically we can say, okay, HU go from A to B, but that doesn't do anything yet. We want this to go from A to B physically. So how do we get from here to a physical movement? Second important object is the queue. And the queue is determined for the warehouse order, and the queue decides whether a task is relevant for the subsystem or not. For queue customizing, and you might have seen that already if you're working with RF, that you have these operating environment where you can say that's an RF queue, for instance, and you also have these parameters here that assign the MFS relevance to the queue. So if you set the queue to MFS environment, then the system will set a flag in the warehouse task that flags the given task as relevant for the subsystem. I will show you in detail on the next slides. Just one more thing. In addition to the relevance, you also assign the PLC as such to the queue. And we to the PLC in the next slides, but for now, remember that warehouse tasks are communicated to a PLC in case the queues are flagged as relevant for the MFS, for the subsystem. And the PLC as such is also directly assigned to it. KZ sub is the field in the warehouse task data which is relevant to flag and identify a task as being subsystem relevant. And this flag is actually set in the context of the queue determination. So I gave you here a screenshot from the coding. So in this function module where we determine the queue, we read table T346, and here the queue customizing is sitting. And here we have a look at the operating environment. You see these two constants here are the two operating environments that you saw on 1-2 slides before, where the MFS relevance is set. Yeah, so these are constants 4 and 5 here. I go back for you 2 slides here. These two guys here. And if they are set to 4 or 5 in the queue, so at first EWM determines the queue, then EWM checks the operating environment, and if this is 4 or 5, then this KZ sub-variable is set to Y, which means it's relevant for the subsystem, but the task is not sent to the subsystem yet. And that's important. Remember, the queue is an important object, and the queue determination tells us whether a task needs to be communicated to a subsystem or not, and if yes, what is the PLC we need to communicate it to. PLC is also linked to the queue. So we've learned now a task which is assigned to a PLC relevant queue needs to go to the physical PLC. So we have a logical PLC created in EWM, and that's our third important object for the EWM MFS integration. We talked about communication point queue, and now we have the logical PLC, which is derived from the queue, which is MFS relevant, and mapped to this logical PLC in the EWM MFS component, we have our physical PLC. And when I say mapped, it means the details of the physical PLC are saved in EWM. And this is, again, something which is defined as master or application data and then enriched in the customizing. Master data level, we define the way of communication, for instance, whether we communicate via our push channel or we have an RC converter like plant connectivity in between. And in the customizing, for instance, we configure additional stuff like the warehouse process type, which is used for put away, for instance, or exception codes or warehouse process types for rearrangement and all this stuff. Question is now, go back, when we have identified the PLC, we have identified that the task is relevant for the subsystem, how do we actually communicate it? And here, the next important object is coming into the game, which is a telegram. So here, the transfer of the task to the subsystem, to the physical PLC, this is done via telegrams. And a screenshot of a standard node from the warehouse monitor, which shows telegrams. And the telegram, as you can see it here, is nothing else than a string of data. Yeah? It has a header structure and an item structure. And this is also something where we go in detail in one of the next videos. For now, just remember the telegram is the message type, let's say, which is used to communicate between the EWM MFS component and the physical PLC. Just to visualize it, here we have the telegram, and that flows between EWM and the subsystem, and the other way around. And how this is being communicated and how we actually connect technically, this is defined in the communication channel. So the communication channel is the next important object that I would like to highlight here for the integration, because the communication channel tells EWM like how it can reach the physical PLC. So it gives us information like the host, the server where the PLC can be reached, and the port, and so on. Here you see an example of a communication channel which is created for a PLC, and you see the connection data which is needed in order to reach it, for instance, via TCP/IP based communication. And again, there is customizing, which enriches the application data here, for example, with details about the communication protocol, like retries, processing, sequence number handling, and all this stuff. This is needed that EWM can actually talk to a PLC. And as you learned in the previous video, a PLC in terms of a CPU or a program running on a CPU, and which can then process the data from the telegram. But as I said, I would recommend to check the PLC introduction video if you want to learn about how a PLC is actually being set up and what it is doing. I don't want to go into detail again here. To wrap it up, before we come to the last important object, HU moves from A to B. We have the communication point, and we have the queue, which flags the movement as being relevant for the PLC. A PLC as a logical object in EWM has a communication channel assigned to it, and the communication channel holds the data which is relevant in order to communicate. Like, it holds the technical details which are needed in order to send a telegram string, for instance, via TCP/IP protocol from EWM to a PLC, which is a small industrial computer which is running some programs to process information coming from EWM or from the subsystem. Last important object is our resource, as it might be that we do not have such an easy example like here, where we just move a pallet on the conveyor from A to B, but we might be in the next step where we have this transfer car, we might have a crane which is moving pallets in or out of an automated high bay. And these resources are processing multiple objects, and they need to be maintained. Their status need to be maintained in EWM. And this is then our last important object in this context, as here this resources control the processes from EWM MFS perspective in such an environment. And again, we have application data here where we have, for instance, an error bin where the resource would drop an HU in case there is some error within the communication, or we have like telegram processing details and, for instance, a maximum number of transfers which can be processed for an object before it is moved to some kind of special clearing or rearrangement bin. But those details are not that interesting right now. For you, it's just important to understand that, like, automation equipment, which is processing task one by one, is reflected in EWM MFS as a resource. Yeah, and that should be it as an introduction of the most important objects in EWM MFS, which are used to integrate EWM core with the MFS component and the MFS component with the physical subsystem. And to close our example that I raised at the very beginning, where we moved the HU logically from bin A to bin B, we now moved the HU physically from conveyor segment A to conveyor segment B. And we did that based on a telegram, which was moved from EWM MFS via communication channel data to the physical PLC. On the physical PLC, in the memory of the CPU, there's a program sitting, which is interpreting this telegram, this data string coming from EWM, and it understands, okay, I have a source and a destination in this data, and EWM wants me to move an object from this conveyor segment A to conveyor segment B. And then the PLC has some output that it controls, so it switches on some sensors and some drives. So in this example, it activates the drive of the conveyor segment A, so the pallet starts moving. Then it hands over the HU from the segment A to the next segment, and so on, up until it finally reaches segment B. And when the HU arrives at segment B, then the PLC again sends such a telegram via the communication channel data to the logical PLC in, let's say, to EWM, and then EWM grabs the string, processes the information, and understands, okay, that was the HU that I wanted to send from A to B. It arrived now at B, and okay, I can confirm the warehouse task, which the HU, and can confirm the HU on bin B, and might then create a follow-up warehouse task and send the next telegram to the PLC to move the pallet from, let's say, bin B to bin C or so. Yeah, that is actually closing our example, and that is also closing this video. I wanted to keep it a bit shorter this time. I hope that this gave you at least a rough understanding about how EWM and EWM MFS communicate with the subsystem. I hope you have an understanding of the most important objects now. I didn't want to explain all the details with this video. I wanted to give you a good base for understanding the next videos, where we will give like step-by-step overview about the communication. On the one hand, from EWM to the PLC, we really go into technical details here, and on the other side, from the PLC to EWM. I would highly appreciate if you would subscribe to the channel, then you wouldn't a notification once we release the next video, and feel free to browse the website of the Swisslog EWM team. I would like to say thank you again here for the support from Swisslog in providing the expertise and providing the opportunities to access the knowledge of the team here, and wrap this into a video that hopefully helps you and the community. Yeah, with this, thanks for your attention, thanks for your time, and I hope to see you again with the next video where we proceed discovering EWM MFS. Thanks and goodbye.